Okay, hello everyone. Okay, so the next program in chapter 5 is prime number list. Prime number list. Okay, so use the isPrime method that you wrote in Programming Challenge 13 in a program that stores a list of all the prime numbers from 1 through 100 in a file. Okay, so if you remember, the previous program, the program before this one, was an isPrime method. Let me just pull it out. I think I have it here. Yeah, so it was an isPrime method, and basically, this isPrime method has a function defined, has a method defined, and it takes in one argument, which is a number, and it returns true if that number is a prime number, and returns false if that number is not a prime number. So the program is telling us to use this method to basically display all prime numbers starting from 1 through to 100. We should go ahead and write that to a file. So a file should basically store a list of all the prime numbers from 1 through to 100. So let's start. But since we're going to be using this method, I want to make a copy of this program, delete what's in the main method, and then create this program that way. So what I'll do is I'll first of all I'll copy this question, and then I'll delete this file. And then I'll save this isPrime method file as the new file, which is called prime number list, I think. Let me just paste this and see the name of it. Prime number list. Okay, so I'll undo this. Alright, so I'll go ahead and save this file as, let's see. So I'll create a new folder in chapter 5 and I'll call it prime number list. And then I'll save this one as prime number list.java. Which means I also have to change the name of the class, the main program. It's class. Okay, the main program's class. I have to change the name to match the file name, because the file name, the name of the file has to match the name of the class. So I'm going to save this here, and I'm going to change this to prime number list, which is going to be our new program, and I'll compile it, and it's fine. Well, the last thing I'll do is I'll just change the question to what I copied. So I'll paste that. Then now we have the new question here. Okay, so I'll go ahead and delete what's in main, because we don't need this yet. All right, so basically we have, this is the new program, prime number list. We have the method defined. The method again takes an argument, which is any number, and it returns true if that number is a prime number, and returns false if that number is not a prime number. So it wants us to basically list all prime numbers in the range of 1 to 100 inclusive. It wants us to print all prime numbers in that range into a file. So since we're going to be using a file, we need to go ahead and import java.io.asterisk. Okay, so we need to go ahead and import this, since we're going to be using some of the methods, and basically since we're going to be using this class or this library, we need to go ahead and import that so the program can have access to it. All right, so now we have the method defined. This is our main method, so we're going to be working in our main method. In the main method, I want to go ahead and create a new print writer object. Okay, the print writer object is going to allow us to basically create a file and write to it. So I'm going to create a print writer object. And I'll call it file to write. I'll call it file to write, because it's going to be the file we're going to write to. I'm going to create a new print writer object in memory, and now I need to give it the name of the file. I'm going to create a name. So basically this statement is going to create a file for us, and then associate that file object to this variable. It's going to create a file in memory, a file object in memory, and associate it to this, or connect it to this variable, which is going to be a variable that's going to hold. It's going to be a reference to the file object. So the name of the file, I'm going to call it prime. Let's see, prime numbers.txt. I'm just going to call it prime numbers.txt, and So now basically this statement is going to create the file for us. So we can use this to basically write to the file. The next thing I'm going to do is now I'm going to create a loop. Since the program wants us to start from 1 all the way to 100 and print all prime numbers within that range, inclusive, okay, 1 all the way to 100, I'm going to create a loop to start from, which is going to start from 1 all the way to 100, and each time it's going to test the number from 1 all the way to 100. Because in the loop, each time it iterates, 1 is going to be incremented each time, or increased each time by 1. So it's going to start from 1 all the way to 100. Because in the loop, each time this current number starting from 1 is going to go up by 1 all the way to 100, we're going to check that number to see if it's a prime number. And if it's a prime number, we're going to print it to the file. And we have the file object here already. So let's go ahead and create a loop. I'm going to create the structure of it. Okay, so I want to start and create a variable which is going to keep track of our current number. We're starting from 1 all the way to 100. Okay, so it's going to be an integer because we are dealing with integers here, 1 all the way to 100. So I'm going to create an integer. I'm going to call this variable current number. It's going to be our target variable. So current number is going to start from 1. Okay, and as long as current number is less than or equal to 100, do what's in the loop. Go ahead and do what's in the loop, and before you come back up and check to see if current number is less than or equal to 100, add 1 to current number. Okay, so we are basically initializing or starting current number with 1, or basically we are starting from 1. Current number is starting from 1. It's going to go ahead and do what's in the loop. Well, before that, let me start again. Current number is going to start from 1. It's going to check to see if current number is less than or equal to 100. In that case, if it's starting from 1, initially 1 will be less than or equal to 100. So it's going to go ahead and do what's in the loop. And before it comes back up and check to see if current number is less than or equal to 100, it's going to add 1 to current number. So current number is going to start from 1. It's going to check. Is current number less than or equal to 100? It will be, because 1 will be less than or equal to 100. It's going to do what's in the loop, add 1 to current number. Now current number is 2, and it's going to check to see if 2 is less than or equal to 100. It's going to do what's in the loop, add 1 to current number, and current number is 3. It's going to check to see if current number is less than or equal to 100. 3 will be less than or equal to 100, so it's going to do what's in the loop, add 1. So basically it's starting from 1, making sure that it's less than or equal to 100, doing what's in the loop, and incrementing 1 and checking again. So basically that's how the loop is working. So each time this current number variable is keeping track of our current number, because it's starting from 1 all the way to 100. It's going to be incremented. We will know basically this variable is basically going to keep track of all the current number. Okay, so each time it's doing that, let's go ahead and so basically this loop is starting from 1 all the way to 100. So each time it's iterating, we want to basically check to see if that number is prime. We have the name of the method here, isPrime. So we can, in the for loop, we can create an if statement and say if isPrime. Now if isPrime takes an argument, which is basically any number, to check to see if it was to check to see if it was a prime number or not. So if isPrime, the current number, if the current number we are in the loop is a prime number. Now this isPrime method returns true, okay, if the number that you're passing into the method is a prime number. It returns false if the number that you're passing into the isPrime method is not a prime number. So basically this statement, isPrime current number, is going to return true if the current number is a prime number. Now assuming it was a prime number, assuming let's say the current number right now is a prime number, so it's going to return true. So in place of this whole statement, we're going to have true. Now this block of code we're going to write here is going to run only if this results into true. Okay, that's why I wrote it this way. If isPrime current number, it's going to return true if it's a prime number. So if it's true, then do what's in the code. If it's false, what's in this if block wouldn't run. So this is equivalent to doing something like if its prime current number is equal to true. You don't have to do this though. You don't have to. It's not necessary, because if this will return true, this whole statement will return true. That's how we define the method. It's going to return true if the current number is a prime number, or return false if the current number is not a prime number. And if this whole Boolean expression basically results to true, it's going to go ahead and do what's in the loop. If it returns false, it's not going to do what's it's going to go ahead and let me say it again. If the isPrime current number method returns true, what's in this if block is going to run, not the loop necessarily. What's in this if block is going to run. If the isPrime method returns false, what's in this if block wouldn't run, but the loop will still keep going all the same. All right, so if it's a prime number, what we want to go ahead and do is basically write that number into the file. We have the name of the variable that's representing that file here, this file object. So basically here, file to write. So we can go ahead and say if it's a prime number, then write to the file, basically write to the prime number to the file. So file to write. We can use a method with this file object, file to write object. We can use a method with it. So file to write dot print. There's a method called println in that class. So we are writing to the file. And what are we writing to the file? We're writing the current number to the file, because we were able to tell that, or we're able to prove that that current number is a prime number. If it's a prime number, if this whole statement returns true, then go ahead and write the current number to the file. If not, then don't do anything. Keep on iterating. Don't do anything. While you're iterating, write to the file only if the current number is a prime number. So basically that's what we're doing. And once you're done with everything, once you're done with the loop and you've written all the items to the file, we have to go ahead and close the file. So file to write dot close. It's important to close the file. Sometimes if you don't close the file, your files wouldn't be written. Sorry, your items wouldn't be written to the file. Your numbers wouldn't be written to the file, because it's because of the way writing to a file and all that stuff works. Initially, while you're writing to a file, it's storing the items you want to write to a file into something called a buffer, and it only writes to the file when the buffer is full. So you may end up writing to a file and the items will be written to the buffer, right? But then it wouldn't be full, and then you would wonder why the items weren't written to the file. That's because the buffer is not full. Now, closing the file forces anything that's in the buffer to be written to the file. So sometimes if you don't close the file, you may have items that you want to write to the file sitting in the buffer. Because you didn't close it, the items weren't forced to be written to the file. So that's why it's important. So just close it. Just close the file, and anything that's written to the buffer first will be forced to be written to the file. The reason why that happens is because it helps. It's faster to write to a buffer than to the hard disk. I guess or something around that explanation. But yes, close the file and you'll be fine. Once you close the file, everything that's in the buffer will be forced to be written to the file. All right, so now we've closed the file, so everything will be forced to be written to the file. So now let's compile this program and see what happens. Okay, we have a couple of errors. I forgot to terminate this line, so I'll terminate it here. And another error. Let's see. File not found exception must be caught or declared to be thrown. Okay, so what is happening is this. Basically, chapter 5 doesn't cover exceptions yet, right? So we learn about writing code to handle exceptions, or basically errors, right? So the reason why it's prompting an error is because it's basically saying that, hey, this main method we have here has code inside of it that has the potential to cause an error. An example of an error will, for example, be we were creating a file, yeah, right? But what happens if, for example, our hard disk is full, and it doesn't have any space to write the file. It's going to basically crash or basically cause the program to stop or cause some kind of an error. So in that case, this program has some kind of code, and I've pointed out one. Okay, so it has some kind of code that has the potential to cause an error. And the type of error that it can cause is basically an IO error or an IO exception. So, like I said, we haven't learned exception yet in chapter 5. It's in chapter 11. But until we do, we are going to tell the program to handle it for us. Okay, you have to basically tell the program to handle the code or the code that has the potential to cause an error. You have to basically tell the program to do that for you, but you have to also point to the program where that code is. So the way you do that is in the method that the code is in. So basically where the method header is. So in this case, this code that has the potential to cause an error is in the main method, and it has the potential to cause an error. So because this code, which has the potential to cause an error, is in the main method, in the main method header, I'm going to say this method throws, IO exception. I type it correct? I don't know. Oops. Exception. All right. Throws IO exception. I hope I wrote it correct. All right. So basically, what we are saying is this: we are saying this method. So basically, you add the throws IO exception to the method header, the method that contains the code that has the potential to cause an error. We are doing this and telling the program or the program this. We are saying, hey, we haven't learned how to write our own code to handle exceptions yet. Until we do, please handle it for us. And we are saying this method has this code that can cause an error. We haven't learned how to write our code that can handle exceptions ourselves. So until we do, in chapter 11, please, I've told you that, hey, this method has the potential to throw an IO exception. So please handle it for us. Handle the code for us when that happens. So basically that's what we are doing. So yes. All right. So that's why I was complaining. So let's. I think I wrote it correctly, but let me go ahead and compile this and see what. Okay, now it's fine. So basically, yes, we have told the program that this main method has the potential to cause an error, potential to cause an IO exception. So when it does, please handle it for us until we learn how to write our own code to handle exceptions. Now, if we had a method, in here that had, for example, if we had another method, let's say in this main method, that had the potential to, let's say, cause an IO exception, we would have to also end that method. So we have to end the method header with throws IO exception, because that method also has code that has the potential to cause an IO exception, and because that method also sits within the main method, we also have to add throws IO exception at the end of the method header of main. So if you have a method sitting in here, that has code that has the potential to throw an IO exception, you have to add the throws IO exception to the method header. But because that method also sits in the main, it doesn't matter if main doesn't have to have code that has the potential to cause an IO exception. Now, just because the method in main has the potential to cause an IO exception, you have to end throws IO exception on the method header of the method sitting in main that has the potential to cause an IO exception. And also, you also have to add throws IO exception at the end of the main method header. So I hope I explained it well there. So I compiled it. Don't worry too much. For right now, like the goal, like I said in the beginning of the program, these programs, the goal is to just solve the questions without, while trying to explain a bit. But actually, the main goal is just trying to go straight to the point and solving the question. That's why some of these we're just solving it. But once I'm done with the programming challenges of the various books, Java, Python, C#, once I'm done with those, or even in the middle of those, I'll start teaching the Java course. I'll start teaching the Java programming language. I'll start teaching C# and Python and other programming languages as well. I'll teach the programming language and from concept by concept, step by step. So we really understand what we're doing. But for now, the goal is to solve the questions while trying to explain a bit. Okay. So I hope the bits of explanation helped. Okay. All right. So now let's run it and see what happens. Now, one more thing. When we are done, let's go ahead and also print a message, because we wouldn't know if all the files had been written. So let's go ahead and print a message here and say that all the numbers have been written to a file. So system.out.println. We're going to say all prime numbers have been written to the file. Well, basically simple, written to the file. All right. And then now we can run this and see what happens. And now it says all prime numbers have been written to the file. Now, nothing necessarily happened, but actually something happened behind the scenes. Wherever we save this program, because we just wrote the name of the file like this, wherever we save this prime number list.java is where this file is going to be saved. If you wanted to save this in a different location, you can for example, if it's in documents, you can do C:// and then you can say document /prime numbers.txt if you wanted to save it in this location. Okay, if you wanted to save it in this location. Now, of course, we'll have to go ahead and escape some of these. I think so. Yeah, we have to go ahead and escape some of these. But, like for example, these, we'd have to go ahead and escape them. But yeah, you'd have to enter the full path. Okay, we'd have to enter the full path to it into this method. Into this parentheses. Okay. Yeah. All right, sorry about that. All right, so yeah, but because we just wrote the name prime numbers.txt here like this, it's going to save the text file wherever we save the prime number list.java. In this case, I saved mine in a folder, so I'll go to it in a moment. But yeah, that's what we have to do. If you just type the name, it's going to be saved where the Java program was saved, and if you type the path, it's going to save it basically where you specified. So I have the file on my desktop, so I'm going to go to Java here, Programming Challenges, Chapter 5. I saved it as prime number list, and we can see here that the prime numbers.txt has been created. Now, if I open this, I can see that I have all prime numbers in the range from 1 to 100. So basically, these are all the prime numbers within 1 and 100. Okay, inclusive. Okay, one all the way to 100. These are the prime numbers from 1 to 100. So we can see that it's working. We can even try to test this more and say, okay, give me all the prime numbers from 1 to 200, and all we have to do is change. We can basically specify the range over here. Okay, we're starting from 1 all the way to 100. We can say, give me the prime numbers from 6 all the way to 50. Compile this program, run it. Oops. Go back and check. Where is it? Okay. I happen to have it here, but it's on my desktop. Java. Prime number list. So basically, prime numbers from 6 all the way to 50. And you can see here the prime numbers. I'm going to change this back to 1 and 100. Compile this. Run it. And now we can see that it's here. Okay. One more. 5 to 50. Compile this. Run. I have to refresh. Basically, open the file again. Let's go. 5 to 50 here. Okay. Take this back. And it's working. Okay, so we're done. If you have any questions, please comments down below, and I'll do everything to respond to them. Thank you very much for watching. Take care of yourselves, and I'll see you next time with the next program. All right, bye-bye.